So do communicate, but they are not versatile as your computers are, right? Their system are built for specific purpose. They can do that specific purpose really well, right? They are typically for purpose, they are not that capable, but they are capable of this specific stuff. So all up to the design for system and make something, right? That there you buy, okay? But with system, done something that solves real problems. So one example is the smart thermostat. Okay, as here, or another one is the smartphone. Smartphone an embedded system. So the whole purpose can get data stuff. So can't basically can't run a game on you can't run a game on that, but can measure where there's the heart rate or right. So it's an embedded system. That's a remote system. So typically embedded systems have different components. For example, the microcontroller, sensor, so it's getting completely stuck in the hands of the but for now, an embedded system is not a single entity. It has multiple components, and all together we call it project as embedded. Okay. Okay. So this is on the last slide. So like our human work, there are different. We have organs, right? We have sensory organs. We have actuators, and we have brain, right? That's the same way, these IoT system or embedded system, they all have three components. These components are physical, right? So this guy. So microcontrollers, these are the physical part of an embedded system. They are the brain. They do communication. They are kind of like computer. They are kind of like the but created, right? They okay. They have microcontroller program. This is not a part of an embedded system. This is how we program these microcontrollers. So tell your computer what to do. Okay. Your critical concept is the microcontroller, but the way to program, way to instruct your microcontroller, use the microcontroller program. Right? That's more of a development tool rather than a component. And sensors, like our sensory organs, like eyes, ears, like these systems have sensors. Like that's a ultrasonic sensor that it can measure distance. The other one is yeah, so light vision sensor system. It can take the movie, right? And based on that, it can take the result. And they come to actuators, like your organs and legs and stuff. The embedded system can interact the world. The way they interact the world through actuators. It could be a buzzer, can also sound, or it could be a motor, it can be mechanical stuff. So, so the way these sensors and actuators communicate through communication protocol. So these are the standard accepted ways that these devices communicate with each other. So, like, so for example, it seems and this is completely correct, like these people can speak one language and these people can speak another language, right? But like imagine if that's the case for everything, right? So we can't build anything solid at the end, like we can't standardize it. So there are accepted ways to do like that language. You have standardized languages, like I'm giving you right now. Because since you all can understand English, so you can speak it back to me. That's that. These sensors and actuators, they speak the same language. So for that, you can basically universally access in program and instruct, right? Okay, back to the same thing. So like that, like human body, microcontroller, all have a same aspect, right? also have a processor, right? And the processor is basically the thing that does computation in the computer. So Intel, AMD, and certain companies that make economic processors. And processors are not just your CPU. CPUs are also kinds of processors, but they are different approximately different workload. Okay? And there are microcontrollers. These are equal to embedded systems. So you should understand the difference between them. First, a microprocessor is usually the brain of a general purpose computer. That means they can do a lot of stuff. You can play games, you can do conference, and you can download yeah, you can serve web with it, so you can do all sort of stuff. But a microcontroller is more specific, so it can do a specific task that is built for. Okay, and also microprocessors are very powerful. Microcontrollers are really resource constrained when it comes to microprocessors. Okay. And microcontrollers can be programmed. That means you can basically change how a microcontroller should behave on your own. It's not the case with the microprocessor. Usually, the company that made your laptop or the processor decides what's gonna go there, right? Yeah. Next slide. Okay, so MCU is short for microcontroller unit, right? So this microcontroller unit can do everything. Actually, it does coordinate everything that's happening inside an embedded system, okay? It can coordinate sensors. And also it can do the computation, that means processing. It can act, that means it can control the actuators to interact with the world. Next slide. Also, it can coordinate the communication protocol. So it is the brain of an embedded system. Okay. Next. 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 Okay. So this is some. Okay. This is difference. Okay. So SoC are system on chip. They are the processors. Okay. A module is something with processor with additional component. Like SoC can only do computation. It can do the math, the arithmetic. That's all it can do, and execute instruction. When you combine that ability, like the computational ability with networking, input, output, and memory management, and all those things, you get a module. Okay? Taking that module and putting it somewhere that's easier, like that allows us to easier to interact with these modules is something called a development board. For an example, you can see the module is right within the development board, right? But with additional components. What those additional components do is they make it easier and reliable way to communicate. For an example, it has power supply. So usually when you like take the module and power it up yourself, you need to uh, consider a lot of stuff. For an example, you should provide the right amount of voltage and you shouldn't exceed that amount. Like otherwise, you will burn the module. So for the dev module, it's not the case because they have built-in circuits to handle that thing, right? So that's the thing. So usually when we develop a prototype, we'll work with the development board. And once we are finalized with the prototype, when we go and build the actual thing, we'll take the module and like put it in a, how do you say, a circuit board or something. And that's how we make the actual implementation. But for development, we use development board. So that's why it's called dev board, okay? Next. Yeah, so there are many development boards, Arduino, ESP32, and there are a lot of
there was from STM, and for this workshop, we'll be mainly using ESP32 development board because it's one of the very capable development board that are affordable and easier to get started. Okay, and the major key selling point is it has wireless communication. And Arduino, by default, they don't have any communication aspect. So that's a major point because in the second session, you'll anyways need to connect your embedded system that you build to the internet. So for that, we'll be using wireless Wi-Fi. Okay. Okay. Okay, so now let's get started and you'll be given a toolkit. So basically a development board with additional components so you to get familiar with this stuff, okay? Check, check. Check. Check, check one, check one, check one. Testing one, check. Oh. Check one, check one. Testing one, check, check, check one. Check, check, check. Right. Can you start? Okay, attention please. So let's get started. Okay. So, okay, attention please. Right. Okay, everyone, open the kit box and get the ESP32 development board.
Stay away from the two speakers. Let's say.
Okay. So I guess all of you can identify the development board, right? Okay. So first of all, there is micro USB port. That's how you power up your ESP32 and also upload the code, whatever the program that you write from your computer into the ESP32. Okay. Then there are two buttons. One is reset button and another one is boot button. Okay. What this reset button does is it restarts your entire program. That means it's more like restarting your computer, right? There's a button on the computer. When you press, it shuts down and restarts. Right? It's kind of similar there. And there's another button called boot button, which is used to upload code. Okay. So, sometimes there will be issues. Yeah, and as I told you, that ESP module is intact with the development board, and there's an antenna there, which is for you to communicate with internet. Okay, this is important. So there are two LED lights, right? So when you power your ESP, you should see the red LED lighting up. So if that doesn't happen, please inform an NOC committee member. Okay. Power. Can you do that? Yeah, that. Can turn it off and on, right?
Yeah, you can off.
Okay, let's continue. And there's another test LED button. So we can manually program that button to test our ESP32 board. And we won't be doing anything with the test LED for this session. So it's there for you guys to like play around with if you get the chance.
It's not audible clearly.
Okay. Okay. Attention, please. Okay, pay attention. Everyone, pay attention, okay? So this is the very important thing, okay? So when it comes to a development board, so there are pins, okay? Not all pins are equal. Like they are built differently, right? So here's the thing. There is something called GPIO, which stands for General Purpose Input Output. That means you can configure the pins either as an input or an output. Okay, you need to manually configure them in your program, right? And there are some pins that supports analog signal. Like analog signal means the continuous signals, right? In physics, they are like in real world, most things are continuous. For an example, your sound is continuous, right? It's not zeros and ones, right? And light wave, it's wave, so it's analog. So you can read those data from an ESP32, and not every pin can do it. Only the things marked in purple can actually do it, right? Because this is important, because in the session towards the end, we'll be reading data from an LDR. So LDR, it's light data, so it's analog. So you can't use the other pins. You really need to consider using the pins which support an analog signal, okay? So that's the important thing. So pay attention to this diagram, and there'll be a guide made for you guys, and it will be shared in the presentation, so for you guys to refer these kind of things, okay? And in the guide there'll be a diagram that shows which pins that you can legally use in an ESP32, because there are pins that you can't use. I mean, if you use them in your program, you will basically get into troubles, because the ESP32 itself use those pins to diagnose itself. Okay, so that's how it restarts. I mean, if failure occurs, it will automatically restart. But if you modify those pins programmatically, that means you are like forcing your ESP to restart. That means no matter what you do in your program, you can't fix that problem, because it's something so fundamental, right? So that's what you need to be aware of, right? So that's why pay attention to these pins, and please make sure you read the guide, because there's a diagram that's showing the legal pins that you can use and which you shouldn't be using, okay? Right. So why programming? Right. Okay, why programming? Should you learn programming? Okay, so anyways, programming is the way that we communicate with the computers, right? And we use programming as a language to communicate with computers and devices. So since we want to communicate with computers basically, we need programming. So we are using programming, especially so especially C++, right? When it comes to embedded systems, C++ is the language that's widely used. And for like beginners to get in, there are frameworks. One of the frameworks is Arduino, right? That makes the syntax easier, so that you don't have to worry about the programming language itself to program your Arduino, right? It makes things easier, right? And another tool is something called an IDE. This is set of tools that we can use to develop the program so easily. For an example, it has compiler. Compiler basically reads the English-like language from Arduino and converts that into zeros and ones so your machine can understand, right? And there's a debugger. Debugger means when problems occur, you can use those debuggers to easily trace out where the problem is. So it's basically more like a detective game, okay? When problems occur, you basically divide and conquer. So that's how we call it. in computer science. Okay, so it's more like a detective game. You go there and find your own bug, right? So that's why it's called debugging, right? And the text editor. So unlike notepads, this has like fancy colorings, right? And it's easier for you to develop program with the help of this index highlighting and other things. For an example, if you fail to do something, it can even suggest you to do something. Okay, so yeah, and these kind of tools are integrated together in one single tool that is called IDE. So for your purpose, we'll be using Arduino IDE, which is I think almost all of you have already opened. So I don't have to get into that, I guess. Yeah, so this is the thing. So this is how the workshops will be, okay? We'll use ESP32, the primary microcontroller, and Arduino IDE, and the language that we'll be using is C++, okay? Right, so that is the theory that you want to know, and let's get started. I mean, let's program something, okay? Right. When it comes to Arduino programs, there are several things that are default, okay? So there is a function called setup, which only runs once. That means when your microcontroller starts up, right? When you power it on, the setup runs only once, okay? The loop, it runs continuously. As long as you can provide power, the loop sequence will be going on forever, right? And when you press reset button, then the whole thing is restarted. That means setup is run initially and loop forever, right? So those two are specific to Arduino framework. That means it has nothing to do with C++. It's Arduino. And other things, the third point is a code comment, right? You basically can write plain English to explain about the code and stuff. So it is not included in your program, but it's just there for you to like refer or tell someone else what this code does or something, okay? And braces, that's fourth point. That is also part of C++, which is scopes. For an example, this particular piece of code belongs to this function, that or this particular code should be executed when this condition happen. So we define scopes with the curly braces. And fifth one is also a comment, but it's for one line. The third one is for multi-line comment. That's the thing. And a semicolon, so this is a C++ thing. After every line, you should end it with a semicolon. Otherwise, the compiler won't like interpret that sequence as a complete instruction. Okay, you can open your Arduino IDEs and observe these two functions that are there by default, right? So setup function, as I told you, it runs once. And the loop function, it runs continuously. That means first thing, second thing, third thing, and forever till the end. And then it comes back to the first, second, third, goes on, and it happens over and over again. Okay? And setup is where you initialize and configure. For an example, I told you before, when we have to configure the GPIO pins prior, right? For those purposes, we use setup. And loop is where your logic actually goes. So what you want your microcontrollers to execute, that sequence goes inside the loop, okay? Okay, all the codes used here will be available here. You should it's encouraged to like take note of it or at least scan. Check, 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 check. Okay, and also take a note, take a note of this guide as well. Shit. Not working out.
Check.
Okay, can all of you access the guide? Okay, I need one reference. Okay, okay, so if you go through the guide and there's the first diagram, right? So that is the pinout reference. So that means it tells you what each and every pin can do and what it's capable of, okay? The second diagram tells you the legal pins that you can use in your programs. For the green ones are the ones you can actually use without any issue. The yellow ones, it's better to avoid them because they behave unpredictably. And red ones, you should definitely avoid, okay? So when you build things with the microcontrollers, please refer these guidelines. I mean, these diagrams and stuff. So you won't run into unnecessary issues, okay? That's something you keep in mind, right? Okay, so first let's do the hello world, okay? That's the first exercise in every programming tutorial, the hello world, right? Okay, just go there and type it out in the diagram itself, IDE itself. Okay, everyone please note of this, at least get a photograph of these QR codes because you'll be referring them like over and over again. And this is for guides.
Check. Check mic one.
Okay. Yeah, you can try this code out.
Check. Check mic one. Check mic one. Check mic one. Check mic one. Oh, no. Bad, right? Right? Make it.
Okay, so you guys type the code now. So this is how we execute our code. Okay, this is the workflow. So in the IDE, there is a tick mark. Okay, that means compile. What compiling does is it converts your code into zeros and ones that your microcontroller can understand. Okay, so if there are any issue with your program itself, you can find it at this stage. Okay, just let's go and press the tick button. Okay, this usually happens when you didn't select the board. Okay, so before that, you should be able to select what board it is. Because I told you ESP32 is not only the microcontroller that you can use. There are a lot more microcontrollers, right? You first have to go through and select the board itself. Yeah. So ideally, you should be able to search, okay? But in version issues and stuff, we can't actually do it with latest version. So we'll manually go through and search our board name, okay? It's ESP32 dev module. So you just have to scroll through and find ESP32 dev module. Okay, once you selected the board, press OK. Okay, then you are ready to verify again. Okay, so as you can see a positive message, right? If there were any issues, there will be a red, basically red text saying what problem it is and what you can do about it if you're lucky. And most of the time, it won't say what you are supposed to do, so you have to figure it out yourself, right? Then, so I guess all of you have verified. And if your program is okay, you can go there and upload. So this upload sequence basically gets the zeros and ones and put the zeros and ones inside your microcontroller. This is the first time that your program goes outside of your personal computer, okay?
Check one, check one, check one, check one.
Testing one, check one.
Test, test one.
Check one, check
Test.
one.
Test, test.
Check. Okay. So if you see that writing at some hexadecimal sequence and finally hard resetting, hard resetting via RTS means that means your upload is successful, right? So that, okay. And I hope everyone get a positive message. No, can turn it off and on, right? Yeah. With the people. Expert. She's an expert. Huh?
When you are going around, don't go near the two
Ah,
speakers.
okay. വേല ചെയ്താ വേല ചെയ്താ Okay, so just look at the code, okay? So first of all, there's a setup function and it says serial.begin. So what this does is there is something called a serial stream, okay? That is a port in your microcontroller where your microcontroller can give outputs, right? You can read from that stream through the USB cable and see it as an output, okay? In the setup function, you are just initializing it. And the number you see, this 115200, so it's something called a baud rate. Baud rate means it's more like a speed of the data, right? The speed of the data that's coming from the stream, okay? So what you do in the setup function is initializing your stream in that particular speed so that you can read from the particular stream, right? And in the loop function, you repeatedly write hello world in the stream, right? Then the delay function actually does nothing. That means for 1000 milliseconds, it's idle, doing nothing. Then the loop, as I told you, the loops goes over and over again. That means it goes to the serial print line again and prints out, waits for 1 second and do this sequence over and over again, right? So to observe this, you should open something called a serial monitor, right? So in the terminal output, yeah, Okay, there is an icon, right? Like a magnifying glass. So that is serial monitor. You can use this tool to read from the serial monitor itself. Just press it and you should be able to see hello world. But here it is not. The reason is, I told you, right? There is a speed for the data coming in. That is that number. But in the serial monitor, you are reading it in another speed, right? That means you can't interpret the data properly as it's intended, right? So what you should be doing is toggle the baud rate to match the number that you define. For an example, in this case, that big number, right? Okay, right? Okay, right? Now you can see the hello world printing properly. So that's it. That's the workflow that how you write programs and upload, right? Upload to the ESP32 and get feedback, right? That's the workflow. So now let's do something with the board itself.
Attention, please. Let us have a short 15-minute break. Please remain seated while our members will provide the refreshments. After the refreshments are handed out, you may step outside, and please make sure to return by 10:45 to proceed with the session. Please also use this time to sort out your technical issues with the team. Attention, please. Let us have a short 15-minute break and return at 10:45. Please remain seated while our team will hand out the refreshments. After the refreshments are handed out, you may step outside. Also, please use this time to sort out your technical issues with the team. Thank you.
කට්ටිය පොඩ්ඩක් attention දෙන්න මම සිංහලෙනුත් කියන්නම් මේ අපේ දැන් ඔයාලට 15 minute break එකක් දෙනවා ඊට පස්සේ 10:45 වලට තමයි ආය session එක start වෙන්නේ ඔයාලා ඔය seats වල හැමෝම ඉන්න අපි ඔයාලගේ groups වලට refreshments දෙනවා ඊට පස්සේ ඔයාලට refreshments ගත්තට පස්සේ washrooms වලට යන්න පුළුවන් washroom එක තියෙන්නේ මෙතනින් එළියට ගියපු ගමන් ඔයාලට washrooms බලා ගන්න පුළුවන් අනිත් එක තමයි මේ බ්‍රේක් එක වෙලාවේදී දැන් සමහර අයට එරර්ස් හරි මොන හරි ටෙක්නිකල් ඉෂුස් ඇවිල්ලා තිබ්බනේ ඒ ටෙක්නිකල් ඉෂුස් ටිකත් සොල්ව් කරගන්න ඒ ටිකත් කරගන්න ඔයාලා වොෂ්රූම්ස් උත් ගිහිල්ලා රිෆ්‍රෙෂ්මන්ට්ස් එකත් අරන් 10:45 වෙද්දි හරියටම මේ හෝල් එකට ආයෙත් එන්න ඕනේ
ஓகே நான் தமிழ்லையும் சொல்கிறேன் உங்களுக்கான பிரேக் 10:45க்கு முடிஞ்சிடும் அதுக்கிடையில் எதுவும் டெக்னிக்கல் ப்ராப்ளம்ஸ் எதுவும் இருந்தால் இங்கே இருக்கிற அண்ணா மறக்க மாட்டே கேட்டு சால்வ் பண்ணிக்கோங்க ரெஸ்ட் ரூம் யூஸ் பண்ணணுமெண்டா எங்கே யாரையாவது கான்டாக்ட் பண்ணுங்கள் கூட்டிகிட்டு போகிறோம்
Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1,000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable.
Testing. Check. Check one. Check two. Test. Testing one. Testing 1, 2, 3. Check. Check. Check one. Check. Check one. Testing. Check. Check. Check one. Check one. Magat.
Guys, students, if you have any question, please contact our OC member as soon as possible.
Check.
ඔයාලට මේ මොන හරි ප්‍රශ්න තියෙනවා නම් ඉක්මනට අපේ OC member කෙනෙක් contact කරගන්න.
Check. Check.
අපි session එක තව ටිකකින් start කරනවා.
Test one. Test. Check. Check one. Test. Testing on. Testing on two.
There is a garbage bin near the door. You can put your garbage on.
Check.
ඔයාලගේ මේ කෑම කාලා ඉතිරි වෙන ඒවා මෙතන ඉස්සරහා ඩස්බින් එකක් තියෙනවා. ඒ ඩස්බින් එකට දාන්න. දොර ගාව ඩස්බින් එක තියෙන්නේ ඔයාලට එතන දාන්න පුළුවන්.
Check one. Check. Check. Check one. Check. Test. Testing one. Check.
Okay, attention everyone. So everyone get back real quick. So we are running out of time. Okay, attention please. Let's get started, okay? Okay, everyone, focus on the slide. So there is something called a breadboard in your kit, right? So this is more of a connected set of wires. So we can easily plug and play, right? So how this works is In breadboards, usually those top and the bottom, they are reserved for power rails. That means they are connected wires in the horizontal direction. So it doesn't matter where you plug your pin in. So they all connected to the same wire, right? This is where we usually attach our power supply, right? It can be either your battery power supply, or it could be your power supply from the ESP32 itself. So this is where we usually attach the power supply, right? And so important thing about color coding, always keep your high voltage in red color and low voltage or ground in the green color. So because always at least keep this color coding, because it would make a lot of things easier when you actually debug the hardware, right? So that's one thing. Then in the middle portion, okay, in the middle portion, the wires are connected vertically, right? That means in each column, you have vertically connected wires. So you can access the same wire from vertical direction, right? From each portion, like each portion is independent. Like even in the middle part, there's a top and the bottom, right? The top and the bottom are independent, right? So that's something to take note of. And okay, everyone, let's assemble your hardware like shown in the diagram. Can you all do that? And oh, okay, so if it's not clear for you that blue color line is connected to the pin called GPIO2, I hope, yeah, GPIO2, and the ground wire is marked in black color. And the resistor is ideally, we would prefer near 100, not near 100, like in 100 or like multiples of 100 ohm resistors, okay? And if you need any clarification, just inform the committee member. Okay, in case if anyone needs a reference diagram, go to the guide websites and the diagrams are updated there, okay? And I hope you all set up the circuits well. So if that's the case, you can go and code by yourself, okay? This is the code. So I'll walk through the code, okay? First of all, we define a variable. A variable mean a name for a number, right? Or something else, right? So in this case, the variable is called LED and it's an integer. The value is 4, right? And in the setup, uh, we use a function called pin mode to configure the pin as an output. I told you in setups, we need to configure the pin prior in order for us to use them as we want, right? So pin mode, the LED, which is number 4 in this case, and it is configured as an output. That means you output something from your ESP32. Not you are reading something, but you are outputting, meaning that's an actuator, okay? And if you go into the loop, what happens is, first you write a digital signal, okay, in the pin number 4, which is denoted by the LED, and to high. High means high voltage, right? And then you delay it for 1 second, right? And then you are writing the same LED back to low. That means low voltage. That means the light should be off at that time. And you are waiting for another second. So it should, then the loop goes to the top and does everything like usual, right? So in the end, what you should be seeing is LED lighting up and turning off in 1 second delay. That's the output expected, okay?
Hello everyone. A small announcement to make. If anyone doesn't have drinking water, there's a filter in the back and you can go and drink from there. Thank you.
Students, you can find the all codes in your Google Drive that we have shared before. ඔයාලට මේ ඔය codes ටික එහෙම පේන්නේ නැත්නම් Google Drive එක open කරගන්න. ඒකට ඔක්කොම codes ටික දාලා තියෙන. ඒ කියන්නේ codes ටික මේ බලන්න පුළුවන් drive එකේ.
Okay, I guess most of you successfully did the demonstration, and let's move to the next next setup. Okay, so due to time issue, I have to skip this one, but this is called PWM. So the idea is usually when it comes to real signals, they are analog, as I told you. But these microcontrollers and computers, they can only produce a digital signal. It's not that they can only produce, but these microcontrollers usually produce digital signals. So what we do is we kind of do a trick to make the digital signal appear like they are continuous, right? So here what happens is, imagine we need a sine wave. So that means a continuous wave, okay? But we can only produce high voltage or low voltage. So what we do is we um, we we send a small burst of signal and with varying time width. So by stretching the time, we can make it appear that there is more energy flowing. That way, we kind of approximate the analog signal by digital signal. Okay, that's the idea behind this. And when you do the projects, actually, you may need to use this PWM, especially if you are using motors and stuff. Okay. And so it's basically LED fading and buzzer. And servo motors. So all of these things use some kind of analog signal, right? And that's how they operate these actuators. So we'll be doing one of them, probably. Yeah, probably the buzzer. Okay, can you guys set up the circuits for the buzzer? And also the code snippets are updated on the guide websites if you want. You can go there and directly copy it from the website. And if it's not there, then you can find it in the Google Drive, okay? Okay, attention please. So I'll go through the code simply, okay? So first thing, just look at the code snippet. So first thing you see is something called define buzzer pin 4, right? So this is really common in IoT systems. So the thing is before, right? Before in LED, we created a variable, but here we are using something else. But both of them more or less do the same mechanism. Like if it sees buzzer pin, it replaces with 4, right? But the difference is here before compiling, we are changing it into 4 and then compiling. But in the previous program, after compiling, we are replacing it. So that's the difference, okay? So it's a tiny bit of a detail that you don't have to worry about at this stage, but this is another way to define a variable, okay? But it's technically not a variable. We call it macros because there is nothing stored inside the memory, right? In case if you are interested, right? And other than that, we define a frequency variable. That means the frequency of the buzzer itself. So it's set to 200, okay? And in the setup, so this is the most important part, we configure the pin as an output because we are outputting something, right? We are controlling an actuator, right? So that's why we are defining it as an output. And in the tone function, that is a defined function. That Arduino has the tone function that automatically handles all these sound and those kind of things, okay? So you don't need to implement all it by yourself. You just call the tone function with the buzzer pin and the frequency, and that way it beeps. After that, you just stop the beep, right? Then the loop goes to the tone again, no tone again, tone again, no tone again. So that's why you see hear the beep sounding, okay? So that's the overview of the code. And if everything is fine, we can move to the next setup. So is there any questions or issues? Please raise your hands or give me a signal. So all okay, right? We can move to next setup, right? Okay, we'll be skipping. So we'll be going to okay. Now we'll be moving into sensors. So here you'll be taking readings from the environment, right? So one sensor, but you won't feel them as sensors. Buttons are kind of a sensor because you basically read the voltage and detect whether button is pressed or not, right? So that is how we do in programs, right? But we are not going to do the push buttons now. We'll be moving to LDR. Okay, can you arrange this setup now? Okay, the code snippet is not on the drive folder, but refer the guide website. Okay, there is the diagram and the code is mentioned there. Okay, so I guess, yeah, some of you got this thing working, and we can move to the final demonstration, which builds on top of this demonstration. Okay, so you should be getting this right before going to the other one. So try the people who got it right, try, and other people keep trying this thing until it works. If you have time, try out the next example, because you can refer everything in the guide. So you can try it on your own pace, okay? So I'll be moving to the next demonstration. That's a final demonstration for the workshop 1. And the workshop 2 will be going into IoT part. So people who got this correct, can you try extend your already existing setup into a little more complicated one? So you will be using buzzer and LDR at the same time. So that means you are reading and writing. That means input and output at the same time. So LDRs are for inputs, buzzers are for output. Okay, guys, listen. The thing is, we are running out of time, so and we have to have lunch, and there should be another session as well. So we'll be stopping here, but these resources will be available online. And more thing is, there is a website called Walkwe where you actually don't need any components in the first place. So you can, it's more like a virtual platform that you can try every sensor and stuff. So you can practice with them, you can simulate them. So you can try all sort of stuff. But we would personally recommend you to guys to get hands-on with the hardware if you can, because there are places you can buy this electronic stuff and they are not that expensive as well. So we would encourage that way. But in case if you don't afford them or lack of availability, make sure to check out this website. It's called Walkwe and it's free. You can try out a lot of stuff. But for your projects, please do consider doing in a hardware implementation. That would be, that is always encouraged, okay? And thank you for bearing with me for, I guess, for several hours, I guess. So thank you so much. And I'll be handing over to the, the presenter.
Hello. Hello.
Check. 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 Check.
All right, everyone. Let's break for lunch and meet back at 12:50 p.m. Every group will be assigned an OC member to direct you with the lunch proceedings. You may follow the OC members outside and receive your lunch with them, and they will direct you on where you should go and have your lunch. Please make sure to stay with them until your lunch is finished and return back with them. You may also use the washroom.
attention please මේ students ඔයාලට දැන් lunch එක ready කරලා තියෙන්නේ. එතකොට ඔයාලට අපි lunch එක provide කරනවා. ඔයාලට දැන් තියෙන්නේ ඔයාලා ඉන්න seats වලින් ඉතලා මෙන්න මේ දොරෙන් එළියට එන්න. හරිද? පොඩ්ඩක් ඉන්න. මේ එතකොට මුලින්ම ඔයාලට කියන්න ඕන ඔයාලට අපි lunch ගන්න arrange කරලා හරි. lunch arrange කරලා තියෙන තැනට යන්න අපේ OC එකේ member කෙනෙක් ඔයාලට කියයි direction එක මොකක්ද කියලා. ඒ නිසා අපි 8 තමයි මෙතනින් යවන්නේ.